I want to talk about the limit and the offset additions to an SQL select clause. Let's take a look. Here, I have some data. And this data is not actually altogether that interesting. It's just a couple of names and a couple of values. And the data set might be relatively large. In this case, it's 1,000 values. We could maybe even make it 10,000 values or 100,000 values, although at a certain point, I think we get the idea. As a consequence of these values, I might want to write some system that provides somebody a web-based interface, in which case they can kind of scroll through all the values and see what they are. And so I might want to have a dashboard that shows all of the values that were stored in this database. So some user who doesn't want to use SQL and doesn't want to write select statements can just click on a link and they can see what data I've collected. But they might say, you know what? This page takes forever to load. And every day we collect more data, and every day the page is taking longer and longer and longer to load. So you say, no worries, I'll do what everybody does. I'll paginate the data. I'll limit my query to look at the first 10 rows. And when you click that next page button, I'll just use the offset part of this limit to look at the next 10 rows. And I'll keep in memory how many rows you're looking at one point in time and what your offset is. And in fact, when you use a lot of these web-based tools, you often see that in the URL. You can see in the URL, 25 entries for the clothing website, and you're on page 14. Now, bear in mind, this might fail if you're constantly inserting entries, so they might appear in some weird ordering here. But even if we exclude that entries might be added to this, because you can think that in many cases, data isn't inserted nearly as frequently as data is viewed. And you might say if something is inserted in between when I go to the next page, don't worry, people will just refresh. I don't have to deal with that. There may still be something you don't like about this query. Can you spot what makes this query potentially a problem? I'll give you a hint. Let's take a look at the data that we have in this data set. And you can see we can do things like select the first 3 elements. We can select the first 3 elements offsetting by 3. We can select the first 6 elements, and everything kind of makes sense. Let me show you one small difference that I did. In both cases, I generated the data with the same random seed. But in one case, I inserted them in a particular order. In another case, I inserted them in another order. And I get different results. Does that give you a hint as to what we might be doing wrong with our limit and our offset? If you said that SQL has no natural notion of ordering, and the only ordering that you have is what you project onto the data via an order by clause, and as a consequence, limit and offset should not be used in the absence of an order by clause, you are absolutely correct. This is a fairly common mistake that people make when they do pagination. You must use an order by clause here in order to make this deterministic and in order to make this work correctly. And it's often the case, and let's put this in the right place, it is often the case that if we don't put in an order by clause that gives us deterministic ordering, we can have as a result some very little weird oddities in our data. Let's talk about this a bit. Here's the thing. As a consequence of SQL not having any natural ordering of the data that it stores, they're just tuples that have been written to disk, but the order in which they were written to disk doesn't really mean anything. The only ordering is what's in the data itself. It's often the case that when we do a limit or an offset, well, the limit or the offset is just how the thing read these from disk. And generally, the SQL engine that you're going to operate on is probably going to give you the results of a query with that limit and that offset clause in the order which they were written to disk. But that is not an actual guarantee. You might say, well, I did this 50 times in a row, and the same answer comes back every time. What's the big deal? Consider that if that data were to change, then okay, maybe the SQL engine might be fair to rearrange that data. There are background processes that run in your Postgres databases like vacuuming, and when you vacuum rows, that might reorder things, and you might see a different ordering here. But also note that when you're doing select statements, you're oftentimes doing them in the context of a larger piece of querying work, like a transaction. And in that transaction, you might insert rows and then do a select. Consider that if you had two simultaneous users and they both inserted rows in a transaction, did a select, and then decided not to commit those inserted rows, it should be the case that both of those users see the same thing inside the transaction, and somebody before and after that transaction all see the same things. And the loosening of this requirement of ordering means that unless every one of these users puts a deterministic ordering on their queries, there's a chance that the SQL engine may decide that for whatever reason, for whatever efficiency it wants to seek, it's going to give different orderings for those two users doing the exact same thing at the exact same time within those transactions. There's no guarantee that they get the same result. It really comes down to the engine. What this means is it's important anytime we're producing any sort of values that might be reliant on an ordering, any sort of window functions, any sort of limit or offsets, where it's not just a limit 3 just to see what's there because I'm just spot checking it, kind of like a sample 3 in pandas. If it's a case that we're actually delivering this to an end user, we have to be careful to make sure that we have an ordering, and not just an ordering, but a deterministic ordering. This by itself is already better than what we had before, but it's not quite correct because there's no guarantee that those name values are unique. I need to make that name value a unique primary key in order to make sure that that name and value together give me a correct ordering. If the name isn't unique and the value isn't unique, then I need to find some other mechanism in order to make sure that this is unique. And that may not be possible, in which case I may not actually be able to meaningfully do certain types of things with this. I might always be doing this by the seat of my pants. In general, there's usually some kind of primary key, whether a synthetic one or a natural one on your data. And usually putting that somewhere in your ordering clause at the very end is going to help you get that deterministic ordering, because that primary key will be something that's fixed, maybe some kind of auto-incrementing integer or something like that. Note that even though you may say, you know what, it doesn't matter for my users that these are ordered by anything but the value, there is still benefit in adding in the other fields just to get that deterministic ordering, because it will result in things being a lot more consistent across all of the simultaneous queries that'll operate within your distributed querying, data inserting, data selecting, and data manipulation